Hi, this is the 8th lesson on the topic of electricity, and in this lesson we're going to cover electrical power, and it continues on from the previous lesson on electrical energy. Now, electrical power is seen all around us. It's seen on all of our appliances, like our phones, our devices, and even things like hair dryers. So of these three hair dryers, which is the most powerful? And how would you know? Now we can remember that power is measured in watts. And we can see that the hairdryer at the top has the highest wattage, the highest power of 2500. This means that hairdryer transfers 2500 joules of energy every second. Now, power is commonly displayed on all electrical appliances like batteries and phones. But what does it actually mean, and what is electrical power? Now, traditionally, power is defined as the energy transferred per second. So if something has a lot of power, it means that it transfers a lot of energy every single second. Something that has a low power doesn't transfer that much energy every second. It's given by the equation, power is energy divided by time, and therefore, based on this, electrical power is defined as the amount of electrical energy transferred per second. And therefore, electrical power can be given by the equation electrical energy divided by time. It's really important to distinguish between the traditional definition for power and the electrical definition for power. Now let's take a closer look at this equation. Electrical power can be given by electrical energy divided by time. And now we know in the previous lesson on electrical energy, we came up with a definition and an equation for electrical energy. That was electrical energy is equal to voltage times current times time. Now we can simply substitute this equation in place of electrical energy. That will give us this. Electrical power is equal to voltage times current times time divided by time. So we've taken this part here and replaced electrical energy with it. Now you should be able to see that we can cancel out time on the numerator and denominator. And that will give us the equation electrical power is equal to voltage times current. This is an extremely important equation and is often used in our exams. There's a second equation that often comes up, and to find that we need to go back and revisit another equation that we saw in this topic, and that's voltage is equal to current times resistance. Based on this, we can substitute current times resistance for voltage. So we can replace voltage with current times resistance. And that's going to give us this equation here. So we removed voltage and we substituted with current times resistance. And now our equation for electrical power is current times resistance times current. Or in other words, electrical power is equal to current squared times resistance. These three equations are extremely important, and you will need to write these down and remember them. Let's take a deeper look into these equations. First, let's look at the top equation. In this equation, electrical power is given by P for power, electrical energy is given by E, and time is given by lowercase t. Power is measured in watts, energy is measured in joules, and time is measured in seconds. This is the word equation, this is the symbol equation, and these are the units. Now the next one is electrical power is equal to voltage times current. Once again, power is given by P, voltage is given by V, and current is given by I. So P equals V times I. An extremely important equation to remember. Just like before, Power is given in watts. Voltage is measured using volts, and current is measured using amps. This is the word equation, this is the symbol equation, and these are the units. Let's take a look at our final equation for electrical power. Electrical power is equal to current squared times resistance. So power is given by P, current is given by I, but in this case current is squared, and resistance is given by R. This is the symbol equation, and our units, just like before, power is measured in watts, and current squared is measured in amps squared, and our resistance is measured in ohms. This is the word equation, the symbol equation, and the units. Now let's take a look at some questions. Try and work these out. Pause the video and have a go. So, in this case, we need to calculate electrical power. Our energy is 1 kilojoule, and our time is 10 seconds. The first step is to write the equation. Power is equal to energy divided by time. So in this case, our energy is 1 kilojoule. So power is unknown. 1 kilojoule divided by a time of 10 seconds. Next, we need to convert 1 kilojoule into joules. So power is equal to 1 times 10 to the power 3 joules divided by 10 seconds, which will give us an answer of 100. Not just 100, but 100 watts. Next, in this case, we need to calculate the time. The time it takes to transfer 20 megajoules of energy to a roller coaster motor with a power of 500 kilowatts. Once again, we need to write the equation. In this case, I'm going to write the symbol equation. Power is equal to energy divided by time. Now I know that our power is 500 kilowatts. Our energy is 20 megajoules, and our time is unknown. Now the first step would be to rearrange this equation to make t the subject. We're going to do this by multiplying both sides by t, and also dividing both sides by 500 kilowatts. And this will give us T is equal to 20 megajoules divided by 500 kilowatts. Next would be to convert our units from megajoules to joules and kilowatts to watts. This can be done by replacing the mega sign with times 10 to the power of 6 and kilo by 10 to the power of 3. So 20 megajoules is equal to 20 times 10 to the power of 6 joules, and 500 kilowatts is 500 times 10 to the power of 3 watts. When we put this into our calculator, we get an answer of 40 seconds. That's it. Hopefully you got that right. Make sure you've tried the next two before you watch the video. A bulb had 6 volts across it and a current of 4 amps for 3 seconds. Calculate the energy transferred and the power output. So we have two things to calculate in this case. First, let's calculate the energy. As we know, electrical energy is given by voltage times current times time. Our voltage is 6 volts. Our current is 4 amps, and our time is 3 seconds. We can simply put this into our calculator and get an answer of 72 joules. Okay, let's calculate the power output. Remember, power is equal to voltage times current. Our power is unknown. Our voltage is 6 volts. And our current is 4 amps. When we put this into our calculator, we get an answer of 24 watts. Super easy. Let's try one more. In this case, we need to calculate the electrical power when a current of 1.5 amps passes through a resistance of 200 ohms. Now, we need to make sure that we select the right equation. And for this question, we need to use power is equal to current squared times resistance. Next, we're going to substitute into our equation. Our power is unknown. Our current is 1.5. Remember, make sure you square it. And our resistance is 200 ohms. When we put this into our calculator, we get an answer of 450. Not just 450, but 450 watts. And that's it. I hope this lesson has been useful and it has been clear. If you have any questions, please do ask.